Hello everyone, let us provide a solution to this interesting exponential equation which I have posted on my Facebook page the day before yesterday. 2 to the power of x multiplied by 3 to the power of x squared equal to 6. By guess and check, you can clearly see that x equal to 1 is a solution, because if x is 1, you have 2 to the power of 1 is 2. X squared is 1 squared, which is still 1. And 3 to the power of 1 is still 3. So you just have 3 times 2, or 2 times 3, which is 6. So 1 is a solution. But we have another solution. And I think let us introduce logarithm to find that other solution. I would like to use natural log. So if you take natural log of the left-hand side, which is 2 to the power of x multiplied by 3 to the power of x squared, you have to take natural log of the other side, which is 6. According to another law of logarithm, whenever you have log of a product, it is the same thing as sum of the logs. Let me show you. If you have log of a times b, you can split it into log of a plus log of b, right? So we can apply the same thing here. Since we have a product, we have natural log of 2 to the power of x plus natural log of 3 to the power of x squared, and this is still equal to natural log of 6. Another law of logarithm stated that if you have log of a raised to the power of b, this is the same thing as b times log of a, right? So these exponents can drop down to multiply. So you have x natural log of 2 here plus x to the power of 2 times natural log of 3, and this is equal to natural log of 6. Bring all terms to the left hand side. Let me start with this one. This is x squared natural log of 3, then this one plus x natural log of 2. As this crosses over, it becomes negative natural log of 6, and we have nothing to the right, 0. Observe, this is quadratic equation in terms of what? X squared. This is now the leading coefficient, or a. This is our b, natural log of 2, and this is our constant. Remember the formula, right? Which stated that x is equal to minus b plus or minus square root of b squared minus 4 times a times c divided by 2a. We are going to apply this formula. B is natural log of 2. So x is equal to minus b. That is minus natural log of 2. Plus or minus square root of what? B squared, that is natural log of 2 squared, minus 4ac. But c has a minus, and we are multiplying, so this is going to be positive. 4 times a, which is natural log of 3, then c, which is natural log of 6, natural log of 6. All of this under the square root. Divide by 2a, 2 multiplied by what? Natural log of 3, because that's our e. Now I would like to simplify the content of this square root before we come back. Let me do that here. You should know that natural log of 6 is the same thing as natural log of 2 plus natural log of 3, or natural log of 3 plus natural log of 2, all the same. Why? Because natural log of 6 is the same thing as natural log of 2 multiplied by 3. I remember that law I applied initially, which said that you can split them using addition, log of 2 plus log of 3. So I can write this as this, but we have 4 natural log of 3 attached, 4 natural log of 3. So you have to multiply by this as well. So what if we expand? This time this will give us 4 natural log of 3 times natural log of 2. That is the first term. Expand again. This is 4. But natural log of 3 times natural log of 3 would give us natural log of 3 whole squared. But 4 is the same thing as 2 squared, so they can share that power of 2, right? So you have 4 natural log of 3 natural log of 2 plus 2 natural log of 3 whole squared. This is what we have for only this term. But remember, we have another term here. So this is natural log of 2, everything to the power of 2. I just want to minimize space. Then the whole of this is now this one, which I know I can write as, instead of 4, I can write it as 2 times 2 natural log of 3 natural log of 2, then plus 2 natural log of 3, everything is squared. Now, can you see the pattern? First term squared, 2 times the first term times the second term, then plus the second term squared. Remember this. If you have a plus b raised to the power of 2, this is the same thing as a squared plus 2 times a times b plus b squared. So let me relate the terms for you to see clearly. So our a in this situation is natural log of 2. That's a squared. Then 2 times a times b. You can switch this one, I told you, is commutative, right? This is natural log of 2 times natural log of 3, all the same. So this is 2 times what? This 2 is together with natural log of 3. I think, let me rewrite it for you to see clearly. Natural log of 2 squared plus 2 times natural log of 2. Natural log of 2, because we have 2 of these 2's, right? Natural log of 2 for the first term. Then multiply by 2 times natural log of 3. So you can see the 2 at the 2, which are here. Then plus 2 times natural log of 3 squared. So can you see the a and b? A is this, and b is that, 2 times natural log of 3. So everything here is the same thing as natural log of 2 plus 2 times natural log of 3, everything to the power of 2. This is what we have inside the square root. And if you take square root of this, natural log of 2 plus 2 times natural log of 3 squared, the power of 2 and the square root will cancel. So eventually, everything here is just natural log of 2 plus 2 times natural log of 3. So x is equal to minus natural log of 2 plus or minus natural log of 2 plus 2 times natural log of 3. Divide by 2 multiplied by natural log of 3. So since we have two values of x, let me show you how you can find them. Let's use plus first. So it is going to be natural log of x equal to negative natural log of 2 plus natural log of 2 plus 2 times natural log of 3 divide by 2 times natural log of 3. That is for the plus version. We are coming to the negative version. This and this will cancel because one is negative, the other one is positive. So you only have 0 plus 2 times natural log of 3. And 2 times natural log of 3 divided by 2 times natural log of 3 is 1. So your first solution is 1. Then you use the second version, minus natural log of 2, minus this time around. And this minus is going to affect the 2 times. So all of them will become negative. Natural log of 2 minus 2 times natural log of 3. Divide by 2 times natural log of 3. This and this together will give us what? Minus 2 of this natural log of 2's minus 2 natural log of 3 divide by 2 times natural log of 3. You can write it as, you can factor out the negative sign. So minus outside, inside you have, and these 2's will cancel, right? The 2's will cancel. So you have natural log of 2 plus natural log of 3 divide by natural log of 3. Oh my God. Let me continue here. You can reverse it. Remember, if you have log of a product, you split them into sum. So now you can bring back your first log. So this is x equal to minus just log of 6 divided by log of 3. Right? Oh, are you confused? Okay, let me use natural log. They are all the same. Natural log of 6 divided by natural log of 3. So this is our second value. And I would like to test for this second value, but you should know that according to change of base formula, this is the same thing as log of 6 base 3. So they are all the same place. I would like to use this one in checking my answer whether it is true. We have already seen that 1 is a valid solution. Let's confirm whether this one 2 is a valid solution. This is 2 to the power of x, meaning 2 to the power of this. 2 to the power of negative log of 6 base 3 multiplied by 3 to the power of negative log of 6 base 3 but raised to the power of 2, because this is x squared. So let's simplify this and see. You can remove this negative sign and take reciprocal, right? So it becomes 1 divided by 2 times the positive version log of 6 base 3 multiplied by, you know, this is going to give us twice value, but negative squared is positive. So we have this one squared. This is 3 to the power of log of 6 base 3. I can even put a bracket here and repeat the other one. Log 6 base 3. Another law you should remember, if you have e to the power of log of b base e, provided this base and this base of logarithm, they are the same, this is going to give you b. So this base is 3, the base of log is 3, so you only have 6 here. Do you understand? Yeah, this is going to be 6 raised to the power of what? This one, because the whole of this is 6 raised to the power of this. So let me do that where? Let me continue here. You have already seen the solution. So this is 6 raised to the power of log of 6 base 3. Divide by, because they are multiplying, 1 times whatever is here is that. Divide by 2 to the power of log of 6 base 3. And now you can see they share common exponent. Since they share common exponent, you can give them a single exponent, just like this. Log of 6 base 3. And 6 divided by 2 is 3. So this is 3 to the power of log of 6 base 3. You can see that the bases are also the same, so this is equal to 6. Yes, we have shown that it is equal to 6. And therefore, this is a solution. 1 is also a solution.